The basic workflow for the Internet of Things consists of 4 stages or levels. The sensing layer includes sensors with the ability to sense, compute, and connect with other devices. Try and identify the sensors on your shield. You may have noticed several sensors on the tree-shaped PCB. Sensors can be embedded on the PCB or connected separately. For example, the water sensor detects the presence of water, and water TDS, which stands for total dissolved solids, senses the number of dissolved substances in water. Let's move on to the second layer called the gateway or network layer. This layer collates data from various sensors. In your project, you could say that the router that the microbit connects with is part of the network layer. The next layer is the data processing layer and has numerous algorithms that process the elements sent to it before they are displayed on a dashboard. The last layer is called the application layer. It acts as an interface between third-party applications and the infrastructure. There is a lot more to the architecture than described above, but this is just to get you thinking about how it all works. You also must consider security, as that data could be confidential information and needs to be kept secure from hackers. Efficiency is crucial, as some of these systems will be on 24/7, and throughout the year they need to be reliable to ensure accuracy in critical situations, such as a livestock sensor or heart rate monitors. Data transmission in some remote places needs certain other protocols, such as 4G, using a SIM card, like the ones in your phone to transmit data, as they may not have Wi-Fi capability in those regions. Finally, cost is an important feature when setting up a large facility, along with replaceability of the device in case of damage from adverse conditions. This was a generic architecture design for an IoT setup, and it can vary depending on use cases. Let us do a quick summary of the video.